cracking of an alkane always produces an alkane and an alkene. Give a balanced equation using displayed formulae for the cracking of decane to produce ethene and one other product. So I'll start off then, I'll do decane, which is 10 carbons in the chain. And then I just have to make sure that each carbon has got 4 bonds. So I've put the bonds on there, and then add the hydrogens to each of them. It's a saturated compound, decane, so there's no carbon to carbon double bonds, and it's just a straight chain like this. It's no branching off. And what we do when we crack, we just break the chain up to produce shorter chain material. So we'll still have the same number of carbons, and we'll still have the same number of hydrogens, so we're not going to add anything. So we're going to produce ethene and one other product. So ethene, ene means it's going to have a carbon to carbon double bond, like that. So we've taken off 2 carbons, so that will mean we'll have 8 carbons in the remaining carbon chain. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, just make sure that each carbon's got 4 bonds. Oops, yeah. And then add the hydrogens onto the bonds. And we'll just have to make sure that it balances, just to do a little bit of a sanity check. Now this is an alkene, so alkenes have this general formula CnH2n. So if we've got 2 carbons, we're going to have 4 hydrogens. And this is an alkane, and alkanes have the general formula CnH2n plus 2. So if we've got 8 carbons in the carbon chain, we're going to have double that, which is 16, add on 2, which is 18. So if we add those up, then we've got 10 carbons, C10, and then we've got H22 hydrogens. And if we apply our general formula to this, which is a 10 carbon chain, so double it makes 20, add on 2 is 22. So that's what we got there. So it does balance. We don't have to actually go around and individually count all the hydrogens. We can use our general formulae to make sure that it balances.